Here's a solution to Chapter 10, Problem 15 from the review. The main thing is that this is based on Problem 13, where you looked at the table of planets, their position numbers, and their distances, and tried to come up with a model. And what we notice, if we just go back to that, if we do the scatter plot of distance versus position, it definitely does not look straight, and it definitely looks like the kind of thing where we get a certain incremental growth, and then that growth gets much bigger. That's the picture that one often has of exponential growth. You can test that often by looking at this and looking at ratios. This thing almost doubles from 1 to 2. And then it's definitely a lot bigger, maybe not doubling again. This is, but maybe like 1.5. This is 1.5-ish. This is definitely a jump, and that's something that another problem goes towards. This is almost doubling. This is almost doubling. This is like maybe 1.5. It looks like roughly the factor, the ratio between these is what's roughly constant, not the difference. And that's a sign of exponential growth. Well, how do you tame exponentials? You take the log of them. Okay, so instead of graphing distance versus position, I did the log of the distance, and let's wait for it to come back here. I did the log of distance, and let's put that in here. Okay, so no note on the TI, of course, you'd have something like L1, you'd have the position numbers entered in, and then maybe L2, you'd have the distance, and then you'd go up to the top on the stat edit menu, and you'd say L3 equals, and you'd just do log of L2. Okay, and then you'd go ahead and do a stat plot of L1 and L3. Okay, so this looks definitely much closer to linear. Let me use Fathom here to do a least squares regression. Okay, doesn't look too bad. Our R squared is 0.98. Now remember, that's not a guarantee that this is the best possible simple model, but it's definitely saying we're on track. Okay, and you can of course do on the TI, you would do stat calc 8 for linreg, and don't forget to do, this would be L1, L3, and don't forget to go to vars, yvars function to get y1. So you can plot this, basically this picture on the TI. Okay, and then the other thing, of course, remember that calculates as the residuals. You can either type that in at the head of the stat edit menu, or you can, often it creates it automatically, but there's some finicky things about that. I'm not sure why it doesn't always do it. You can go to second list, which is above stats, and then pull it out of the names menu. It's near the bottom. That's just a way to get resid without typing in. Go to alpha menu and resid. Okay. I know I should show it on the calculator, but this is just much easier to do this than set up the whole setup to show the calculator on the document camera. Okay, and the main thing I'm interested in is some of the subtleties of this problem, the ideas. Okay, so this looks like a pretty decent plot. That's basically 13. Okay, now what about problem 15? Okay. It starts out with something that's a little sketchy, and it's a bit of a confusing problem because it starts out with something that's convenient but kind of silly. It says, hey, there's this other object, Quaoar, okay, which is at 4 billion miles. Okay, so these are in millions of miles, so this would be a 4,000. It suggests first using this existing model to see how well Quaoar's distance compares with the prediction. Okay, well, let's see what the prediction is. That's just a simple aspect of plugging into the model. Here's the model. We have that log dist. It's going to do weird things for me here. Let's see. Log dist. I'm going to try and trick it. Okay, there we go. And let me hat that. So the predicted log dist equals, and I'm just getting it off of Fathom here, 0.271 times position plus 1.25. Okay, so we're just going to plug in 9. We're going to say, well, what if Quaoar were the actual 9th planet and not Pluto? Does that correspond better or worse than Pluto does? The prediction is for the 9th planet, we're just going to plug in 9 here, and we're going to evaluate that. Okay, 3.689. Now remember, that's not billions of miles. That's the log. And so now we need to take 10 to that power. So we're going to say that log dist math mode hat. I'm sorry, distance. Just kidding. Not the log of the distance, but oh, he thinks that's a tangent. That's so clever. I'm just going to put dist. Okay. Is 10 to the 3.689. So that's one of the very few things we need to know about logs, is that to solve a log equation, remember this is supposed to be the mystery exponent, well, we put it in and make it not a mystery anymore. So the distance should be basically 1 followed by somewhere between 3 and 4 zeros. In other words, 10 to that number. And let's have the computer evaluate that. Okay. So looks like this model would predict the 9th planet to not be at Pluto's distance, which is 3.6, about 66 million miles, and not be at Quaoar's distance, which is 4,000 million miles, but actually to be bigger than both of them. Okay, but at least Quaoar is a bit closer to this model at 4,000 million miles. But wait a minute. So that's part A. But wait a minute. That's a little weird. If we're saying Pluto shouldn't be the 9th planet, we shouldn't use a model that used Pluto as the 9th planet to get predictions about the 9th planet. That's kind of very badly circular. So that's why part A is weird, is people usually realize that this is a bad idea right at the start, I think. And part B is really better. So now we're going to just completely delete Pluto and say it really doesn't count as a planet. We're going to put that in as 9. And we're going to put in Quaoar. Okay, and then it has a little bit of a different log dist. Okay, now we're going to redo the least square. So Fathom is nice because it automatically updates it. What you'd have to do here is you just have to do, again, this should be, you might want to make sure this updates. I can't be sure that this is going to update right away. You might want to make sure that this is updated to the new L2. And then you can do the linreg again, and then that gets you your linreg coefficients. Okay, so now what's changed here is that's 273 and 1.24. Not really different. Because Quaoar and Pluto weren't actually super different as candidates for the 9th planet. And now this is going to be 273 times 9 plus 1.25. Let's calculate that. 3.707. Okay. And then the distance. Now, even though this was very similar to before, this can change somewhat because this 10 to a power can exaggerate the differences. Okay. So now it's actually up to 5,093. This model is actually a little steeper, and so it's predicting that the 9th planet would be at 5,000. Okay, Quaoar. So now Quaoar is not really any closer to the model, even though it was included in the creation of the model. And that can happen. These models are not perfect. They're not all supposed to lie on the line. Okay? This guy, it just seems like anything in this region is just going to be low. And this line is not predicting it incredibly well. We could then look at like the goodness of fit. What they ask is, how well does your model predict re-expressed distance from position number fit? Well, it's not super different. The R squared is now 0.98. It's pretty decent. We could look at the residual plot. This does it automatically. Okay. It looks very similar to the residual plot we would have gotten before. I didn't do it before, but it's really not that different. Okay. So this is a cool problem because it's like real life with real, fairly recent stuff in astronomy. But it's a little unsatisfying because there's not an amazing punchline. You're not like, oh, wow, this proves that Quaoar is a planet and Pluto is not. It doesn't really prove anything like that. What I would say is if you look at 16, the next problem, it does some context here. the fact is that nobody's really sure if there is a real law here between position number and distance. There's not enough data. The fit's not amazingly good. It's not like the law between distance and length of year, which Kepler discovered, which was rock solid. That was in problem 12, if you want to look at that briefly again. Nobody's really sure if there's anything to this relationship. It might just be an accident, because we only have 8 or 9 or 10 planets. And what I would say is, a good way to summarize this is, regardless of whether you have Pluto in here as the 9th planet or Quaoar as the 9th planet, neither of them really lend a lot of extra credence to the claim that there is a nice a law of nature here that we've discovered, that there's this exponential relationship between the distance and the position. Neither of them is an amazingly good fit. I think that's all I wanted to say about that problem. All right.